Hi everyone. Today we'll discuss the logistic regression and we will take one example in the data mining for business analytics third edition, and I downloaded the file from datasets here, third edition. The chapter name is Logistic Regression, chapter 10 in the textbook. Please refer to page number 222 for more details. After I downloaded the Excel file, this is exactly the Excel file I will get. Okay, let's see how many rows we have. So we have 5,000 records, excluding the header. Let's do the filter to see what we have here. So here is just like sequence number up to 5,000. The file is Universal Bank, so this is the records. And again, if you need to get more details about this file and the study here, you go to page 222. In this video, I will just show you how we do the steps to run the example in the textbook. Okay, we try to have the data here. So the first column here, you have age in years. So this is the age of the applicant, okay, in years. So this is one. We have experience, and we see experience also in years. There is a data dictionary here you can refer to get more details. Also, you have the description over here. Income, it is in thousands. We have here, so everything here is numerical. We have zip code, we will not study zip code here. It doesn't really, we don't need it as predictor, so we will exclude the zip code. We will take here the family, dependent family size, also it is numbers, so we will keep it. Credit card average, okay, so we will keep it numerical. Education, we see we have 1, 2, 3, and here we have what they mean. So this one is categorical column here, so we need to create dummies for this one because we need to have really like binary numbers. Mortgage here, so we have it and it is numerical, so it's fine. Personal loans, it is already binary number. One, that the applicant was or accepted the loan. Okay, so this is what our dependent response. Okay, it is this personal loan. Yes, one that the applicant accepted the offer. Okay, and here we see, did he or she accept the offer for a personal loan? So that is 1. 0, that they didn't accept the offer. Securities, we see it is also already binary number. CD account, it is already binary number. Online, binary number here. So we are ready to do it, but before we do it, we need really to create dummies for this. So the way you do it, you go to data mining, you wait until you log in, then to transform, we create dummies. Okay, we may get this error message because the data, I deleted one column here. So the formula for the data range here, it takes up to column n, but remember that we deleted the zip code, so now we don't have column n here anymore. So to solve this one, you just go here and you select the data again, and you hit Control A, to select everything, or you can just select it manually. I mean, whatever you prefer to do it with shortcut or to select the range of the data. For sure, the shortcut Control A is faster. Okay, we hit OK. Now we are ready. We have here the education. This is the one we need to create dummies for. We hit OK. Now this is here, you see, this is the data. This is still the same. This is the original data. Here you have the data with the dummies. And the dummies are here. So we have 1, 2, 3. And you see what number 1 means, that you go here and you see number 1 is undergrad, number 2 graduate. So here, so this is graduate. If it is 1, it means the applicant has a graduate degree. If 0, it means it is none. Now, after we did this, we need to partition the data. So the way we partition the data from data mining to partition, standard partition here. Now we select everything. We keep 60/40. This is as per the textbook. I mean, it mentioned that it is 60/40 in page 223. So I'm using the same allocation here. Okay. Now we have 3,000 records in the training database and 2,000 records in the validation database. So now we are ready to run the logistic regression for this data. So we go to data mining, classify, and we select logistic regression. Now here, the first output, as we know, is the personal loan. Is this candidate or this customer like probable or classified to accept the loan or not? So we need to select our output variable. This is the dependent variable as personal loan. Okay. Under personal loan, we have two classes here. We have either 0, not accepting, or 1, accepting. So we are interested in who is accepting the offer. Okay, so we keep it as 1. Now here we need to include the variables. This one is not a variable, so we don't need to include it in the formula here or the variables. This one is not. ID is not. Age, yes, it is. So we add it. Experience, yes. Income, yes. Family, credit card, average, mortgage, student securities account, CD, online. Now credit card. We have educations. Remember, this is the dummies. These are the dummies we created. Number 1, undergrad, maybe number 2, grad, and this is like advanced. So you need, and if you read this in the textbook, page 226, you will see that we use only m-1 dummies. So if you have 4 dummies, you use 3. If you have a 3, you use 2. If you have 2, you use just 1 to avoid any redundancy in the data. Okay, so I will select here number 2 and number 3. Now you may ask me why you didn't select number 1. I'm just following what the textbook has. In the textbook, page 226, they selected education 2 and 3. So again, You can run 1 and 2 or 2 and 3 or 1 and 3. You should get maybe the same result here. Okay, then we hit next. In the next, we keep everything by default, but just we add the statistics here. Now here the model will try different numbers. It will start from the lowest up to 50 here, the highest. So I just left this as the default one. Next, same thing here, detailed. You can also have the lifted chart to see the results for the training and the validation data. We hit finish, and this is our model. We scroll down, so you see that the maximum was 50, but the model used 6. Okay, we have the reading here, we have multiple R, it is like 63, and we have the reading. If you compare these, actually this one here, to the textbook on page 226, you will see that we got the same results. Okay, for all variable predictors and also for the response. Also, the book has the odds, so now we have it here. We have the odds. It is recommended to show these like this. So if you compare this to the textbook, also we got the same thing. We see here the values. It is almost everything 0 except some of them here. And here we will use this in our formula. Let's see the training score. The training score, we will check the confusion matrix. We have total records, 3,000. Now, the applicants who didn't accept the offer, this is the code 0, they were classified this amount correctly, number of records. And these, in the training model, is classified inaccurately. If we take the percentage, we take this plus this, so that is the percentage we got for the incorrect classification for the applicants who didn't accept the offer. Okay, 37 applicants were classified in the training database or training module here as accepted, but they didn't accept the offer. Here we have total 304 candidates. 95 of them, they were classified as not accepted, but actually it is wrong. So if I calculate the percentage, so it is 31. Okay, so you need to be careful with this. Let me just change it. Okay, so this is here. Okay, so this is the formula here. So this is, each formula is different. Okay, so we see that 95 out of the total were classified as accepted. As not accepted, but they were actually accepted, or they accepted the offer. We see overall like accuracy for the training, so we have some errors in the training, and we expect to see the same errors in, or maybe similar or more errors in the validation. If score, as much as it is higher, it is better when you compare between the modules. I will show you here some numbers. And these numbers are the records. So you see the classification here. The actual was not accepted or didn't accept the offer, and the prediction not accepted the offer. And you see here the probability calculated is less than 0.5. And this is why the formula or the model selected this as not accepted. Now here you see that it is more than 0.5. So then the probability is higher than 0.5. The model selected this or classified this as accepted the offer. So that is the mistake here. And for the other accounts as well. Okay, the same other records. Let's see the left chart for the validate for the training. We see this one, and we are interested more in the validation chart. We will see it, and we will see the decile here. Let's move to the validation chart. We see the errors. So this is comparing to the training score. Let's take the training score here. That's what we got here. Okay, as errors. So here, if we use the validation here, so we can see it is higher. Okay, because as I said, the training model, we already have some errors, and these errors affected also the validation. Let's compare this one here for the validation data. So we see the accuracy correct is higher here, and also we see F-score. F-score is a little bit the same, and it is the same cutoff. And we see the same concept here when we show. So if it is below 0.5, then it would be none, or the customer didn't accept the offer or the loan. When it is higher, that means that the customer accepted the loan. So if I need to have less, maybe, if I need to focus more on those people accepted the offer, and I need to have maybe more strict results, we can go back to the standard partition data here, and we keep everything the same, but we will run it again. Data mining, classify, logistic regression, and here we select everything the same, but let's increase this to 0.9. Just let's assume that I need really like that to be really strict in my selection. So we keep everything the same, next, and then finish. You see now XLMINER created a new set of spreadsheets with the number 1. Here you see it doesn't have number 1 because this is the old model we run. Okay, so let's go and see briefly the training. So we see that this is the error, okay, because now we are more conservative. So these the errors here, and we see the confusion matrix as well. We see that it is now for the people like accepted, they were huge percentage classified by the model as not accepted. Why? Because we have the success probability as 0.9. So that is, we will have more errors. If we see the errors here, the percentage of the errors divided on the total for this class, we get really like high percentage here just for this class. Okay, now here you see, if we see the training model again and you compare the numbers here, you see almost like if someone with a probability more than 0.9, so that is classified as accepted the offer. Now here, because actually this customer accepted the offer, the loan, But because the model has probability of more than 0.9 and the calculated probability is 65, so this didn't meet the criteria of the model. So it was classified as not accepted. So this is why we have some discrepancy here. Okay, and if we see the validation score here, so now we are having here also errors. Okay, but you see we are so focused to select really those who are mainly like going to accept the offer. So that is, so let's look here for someone accepted the offer, but I mean as per the model, but actually they didn't. You see, let's see if we find one. So we are looking for a value of 1, but really here to be 0. So let's scroll down. So here we have 1, we have 1, we have 0, we have 1. So we are again looking for a value here 1, but here 0. We need to see, do we have a case where the model classified someone as accepted, but actually they didn't accept? So I don't think we will find that, or at least because we are conservative, we are focusing on those accepting the offers. Okay, so you can do some comparison and get more details. Now let's see the validation chart. On this case, you see the cases here. You see that if you select the cumulative as per the model, you will get more efficiency here as long as it is bigger here. Okay, so I will see this one. So we see now here the number of cases on this side, and we see the focus for these cases here. Okay, so I think I covered the example in textbook, and you can do this exercise to practice and use XLMINER to run this one. Thank you for watching.